So what we're going to try and do is get you to be able to use this to create a direction field. So the first command you have to put in is x equals var, and then put x in parentheses in quotations, and then I'm going to put in t equals var, and then what I want to do is create a direction field for a particular differential equation. So this is going to be the differential equation. I want to do the derivative of x with respect the derivative of x with respect to t. It should be equal to 3 halves x of t minus 1/6 x of t squared. So for Sage, all you need to put into the function is that part right there. So let's go back to Sage. So here's Sage. And the command I want, I'm going to store in this variable v the plot slope field. Okay, so here we go. So I want, what was it, 3 halves. So parenthesis 3 divided by 2 times x, and I believe it was a minus 1/6 times x squared. Now let's check to see if that's true. So let's go back and look at my differential equation. Yep, that is correct. So back to Sage. And then this limits my x-axis. I don't have x anymore. I'm using t. So let's change that to a t. And then this limits my x-axis because this is my independent variable and this is my dependent variable. I'm not so sure what head axis length equals 3 and head length equals 2 or equals 3 is, but we're going to find out here. And then I execute the show command, which should show what's in variable v. So now I hit the run, and there we go. You definitely can see some asymptotes here in the graph. Now, if you wanted to print this out, I think you could do that and then draw your solution curves onto it by picking some points. Now, let's experiment with what happens if I change this to, say, 9. Okay, so let's run it again. Oh, so it's making it larger. So let's go back to 3. Yes, it's making the arrows larger. So now that's a good reason to have those commands in there because it makes you a nice direction field plot. Now, how do you get a solution on there? We're going to have to figure that out. So the way I'm going to do that is I'm going to Google find. Let's see. Let's do solve differential equations. Sage. And here's the reference manual. And so here's the reference manual on how to solve an expression. We're going to use looks like the D solver is one way of solving it, or DE solve computes the general solution of first or second order ordinary differential equations using what a package called Mathematica. So let's see how we can do that. So here's an explanation on how to do that. So let's see if we can solve our differential equation explicitly. Okay? So we're going to have to change a few things here. So let's go back to Sage. Here's Sage, and I think I can create a new window down here. So I'm going to do, I have my x equals var, so I need to change, or sorry, my t, let's change x. X is going to have to equal a function, what was that? A function of x with respect to t. Okay, a function has what we need. Let's check one more time. Yep, that's good. Now let's use dsolve. So I'm going to put in a variable called solution equals DESOLVE parenthesis. Now I have to put my differential equation in. So it's DIFF. Is that correct? Yeah, DIFF, the derivative of x with respect to t, is going to be equal to this expression up here. So I'm going to get lazy. I'm going to do a copy, and then I'm going to paste it down here. What else do I need? I need to tell it what to take the derivative of. Looks like y, or I'm solving for y. So actually I'm solving here for x, and that should be enough. So let's run this again, and I get an error. Keyword cannot be expressed. Okay, so this is all the problems you guys have been having with Maple. Let's see if I can figure this out. Error in line 2-2. Okay, so let's go back and figure out what's wrong with my. Okay, in the example we had, it didn't have that there, so let's run it again. Nope, same error. Let's go back to our solution. So dsolve diff. Aha, I know what the problem is. You see how this has the differential equation in there? Looks like it's moved it over to the side. We have to have the equation equal to 0. So in order for it to do that, the minus sign would go there, and the plus sign would go there. And now let's run the code. There we go. And there is our solution. So we need to solve that for x. So let me pause this and I'll come back. Okay, I'm back. So to solve the differential equation, so we are trying to solve, let's see, let me show we're trying to solve this differential equation now. To get DE solved to work, you can't pass it this differential equation. What you have to pass it, see, on this we have, on the left hand side we have the derivative of x, on the right hand side we have the function of the derivative of x. What we need to do is put everything on the left hand side so that the whole thing is equal to 0. If for us to do that in Sage, I have to call dsolve with this function right here. Alright, then I have to tell it to solve for the dependent variable x. I'm going to store this in a variable s, and then this command prints it out. So if I run this command, I get my solution. Now, I haven't figured out how to get Sage to solve this for x of t, but I'm going to let you guys do that. It looks like Sage calls a log, the so-called natural log. But what you need to do is now take this expression and solve it for x. Once you have solved it for x, we can make a plot. So I'm just going to show you how to make a generic plot. To do that, I'm going to take it and store it, let's say, into a different variable than s, because I used that. Let's call this s1. And let's call this, alright. So now I'm going to call the plot command. I'm going to stick in my function. In this case, it's a linear function of t, and I'm going to range t from the same value of our direction field from -5 to 5 here. And that's how you do it. And then I'm going to run that, and then I'm going to tell it to show me that, which is I have it s1. So there we go. Now, if I use the show command, show v plus s, which is the direction field and the solution curve, well, it'll be your solution curve, but now you should be able to get it to plot those two over top of each other and see multiple solution curves. I hope this helps you doing with Sage. See you later. Bye.